I'm Dr. Fakir. A very welcome to this episode of Clinical Microlearning. Here's a self-assessment question. Which gene is responsible for methicillin resistance in MRSA? A. VAN-A, B. GYR-A, C. MEC-A, D. VAN-B, or E. CTX-M. Please pause this video and think about the answer. The correct answer is C. MEC-A. We can think of Staphylococcus aureus in different groups based on its susceptibility. So we have penicillin susceptible or PSSA, we have methicillin susceptible or MSSA, and we have methicillin resistant or MRSA, which are common in the US. PSSA accounts for less than 10% of Staphylococcus aureus, and Visa and VRSA are extremely rare in the United States. Staphylococcus aureus becomes MSSA due to production of penicillinases that break down penicillin. However, when Staphylococcus aureus has the gene MEC-A, which causes alteration in penicillin binding protein, specifically penicillin binding protein 2A, essentially becomes resistant to most beta-lactams, namely oxacillin, naphthalene, and pretty much most of beta-lactams that do not have activity against MRSA. VAN-A gene is seen in vancomycin-resistant Staph aureus, which is extremely rare in the US, and this is a gene that's essentially acquired from Enterococcus species. So in Enterococcus species, when we have vancomycin-resistant Enterococcus or VRE, this is essentially due to two main genes, VAN-A and VAN-B, which essentially cause ligases to code for D-alanine D-lactate, which is different than naturally occurring D-alanine, which is the binding site for vancomycin. Therefore, vancomycin can no longer bind to D-alanine D-lactate, leading to vancomycin resistance. When it comes to Enterobacterialis gram-negative organisms, beta-lactamases make up the majority of resistance in general. For example, CTX-M, which is a type of ESBL, is not uncommon in Enterobacterialis. Polymorphisms in the GYR-A gene leads to fluoroquinolone resistance. So that's alteration of the site of action for fluoroquinolones. And lastly, you can see the mechanism of resistance to trimsulfa and tetracyclines. Here's another self-assessment question. Rolibactam can inhibit the following beta-lactamases except A. SHEV1, B. CTX-M, C. KPC, D. IMP, or E. AMC. Please pause this video and think about the answer. The correct answer is D. IMP, which is a metallo-beta-lactamase. When it comes to beta-lactamases, they can be classified based on Ambler classification. So when it comes to Ambler class A, we have narrow spectrum beta-lactamases. So these are things like TEM1 and SHEV1, and pretty much all beta-lactamase inhibitors will inhibit these. Slightly more broad beta-lactamases will be the extended spectrum beta-lactamases or ESBLs, and there are different types of genes. There are TEM types, so these are modifications are TEM1, so there are a bunch of them, TEM that we call collectively TEM type. There are also SHEV type, these are derived from SHEV1, so there are a bunch of them, and collectively they're referred to as SHEV1. But more commonly, we have CTX-M, and there are a bunch of different CTX-Ms that have numbering, so collectively CTX-M make up majority of ESBLs. And pretty much most of our beta-lactamase inhibitors do inhibit this in vitro, with the exception of sulbactam. And most broadly in class A, we have carbapenemases. So these are things like KPC, and these are essentially will break down everything, including KPC, including carbapenemases. And we have newer beta-lactamase inhibitors that can inhibit this. So avibactam, berbactam, relibactam, and most recently durlobactam. Then we have class C, which is essentially cephalosporinases. Now, don't let the name fool you. They can also break down penicillins. And these are essentially AMC that are, again, inhibited by more recent beta-lactamase inhibitors. And we have class D that are carbapenemases, but again, these can break down penicillins and and cephalosporins as well. So these are OXA types. So one thing that stands out is OXA48, because OXA48 specifically is inhibited by avibactam. But there are other types of OXA that are not inhibited by avibactam. And more recently, we have durlobactam that essentially has extended coverage compared to avibactam. So it can inhibit OXA48 as well as a lot of other OXAs. And class B is different than class A, C, and D because these are metallo-beta-lactamases, and examples include IMP, NDM, and VIM. And these are, again, carbapenemases that can as well break down penicillins and cephalosporins, and we don't currently have beta-lactamase inhibitors that can inhibit these. Make sure to subscribe and like this micro moment video.